Radians to degrees. This is video number 3. In this video, I'm going to teach you how to sketch the angle given the radian measurement, identify which quadrant it lies on or which axis it lies on, and then convert from radians to degrees. What I do not want you to do is to start by converting from radians to degrees and then graphing it. Let's get started. When we think of our common angles, and when I say common angles, I'm talking about 30, 45, 60s. When we think of these common angles that we spoke about earlier, remember that the denominator was always a 6 or a 4. And so when I provided a radian measurement and I'm able to convert it into an equivalent fraction that's a 6 or 4, it's going to help me to graph it. So in this case, I'm asking myself, I'm not provided with a 6 or 4, but can I easily get there by multiplying? And I can. I can take 3 times 2, and I'm able to achieve 8 pi over 6. Notice that if I multiply the denominator by a value, I have to also multiply the numerator by the same value to keep the fractions equivalent. So now I'm going to graph 8 pi over 6. Since this is a positive value, I'm starting here, and I'm counting. For those that remember in a previous lesson, I want you to think of this as using the pink. And so I'm counting here as 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6, 6 over 6, 7 over 6, and 8 over 6. Show me where that terminal angle lands. This lands in quadrant number 3. Now how am I going to convert from radians to degrees? So I'm going to start with what I'm provided, 4 pi over 3. And similar to videos 1 and 2, I'm going to multiply by a fraction, but this time, instead of it being pi over 180, it's going to be 180 degrees over pi. What happens is the pi on top and the pi on the bottom, you may think of them as being canceled out. Really, they're reducing down to 1. And so on my calculator, I'm going to take 4 times 180, and then I'm going to divide it by 3. This converts to 240 degrees. Let's look at example number 2. Example number 2 is easier than example number 1 because I'm given a radian measurement that already has a 6 or 4 on the bottom. It's a 4. So if you're thinking to yourself, what is she talking about? This is what we're referring to in our previous lessons when we used the green triangles. So think of it as a reference angle of 45 degrees. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So the terminal angle lands in quadrant number 3. Now how am I going to convert? 5 pi over 4 times 180 degrees over pi. On my calculator, and again you can use Desmos at home, I'm taking 5 times 180, and then I'm going to divide it by 4. This is equal to 225 degrees. Let's look right now at example number 3. I would like you to press pause, complete example number 3 on your own, and then come back to see if you correctly were able to find the terminal angle, identify the quadrant or the axis it lies in, and convert it into degrees. Again, example 3, like example 2, is nice because I already have a denominator that's a 4 or a 6. So I'm thinking of a reference angle like the pink triangle. 1 over 6, 2 over 6, 3 pi over 6, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So it actually lands on the y-axis. So it went around one time, and then the second time it landed right here. So it's not actually in a quadrant. Think of the quadrants as rooms, and it's actually on what we can think of as a wall. So it lands on the y-axis. It lands on the y-axis, not in a quadrant. Okay, I'm going to take on my calculator and take 21 times 180, and then I'm going to divide it by 6. I end up with 630 degrees. there's two things different about example 4 and example 5. The first thing is we now have a negative radian measurement. And the second thing is when I look at the denominator, it's not already in the form of a 4 or a 6. So I asked myself, how can I convert 3 into 4 or 3 into 6 with ease? So I know I can take 3 times 2. And whatever I multiply the denominator by, I must also multiply the numerator by. So I have 20 pi over 6. So I'm going to reverse because it's negative. When I think of a 6, I'm thinking of the pink triangle. So reversing backwards because it's negative. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13 pi over 6, 14 pi over 6, 15, 16, 17, 18, 19, 20. So what did I do? I reversed one revolution and came all the way back around to this position. This lands in quadrant number 2. Now to convert it, I'm going to take it times 180 degrees over pi. Grabbing a calculator or using decimals, 10 times 180 and dividing by 3 equals negative 600. Make sure to include that negative sign. Please go ahead, try our last example of this video, example number 5, pressing pause and coming back when you're done. How do I turn the denominator into a 4 or 6? It does not matter whether you turn it into a 4 or a 6, it will land in the same location, and I'm going to demonstrate that. For somebody who said, I want to turn this into a 4, I would multiply by 2, and I'd end up with negative 22 over 4. Excuse me. For somebody who decides to turn it into a 6, you would multiply by 3, and you'd have negative 33 pi over 6. I'm going to show you how these two land at the same location. Let's start with the 4s. So with the 4s, I'm thinking of a reference angle that is green. So I'm going backwards. So here's 1 out of 4. 1 pi over 4. 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16. So notice I've already done 2 revolutions, right? 16, 17, 18, 19, 20, 21, 22. So I'm coming all the way back here. Now that does not land in a quadrant. That lands on an axis. It lands on the y-axis. Let's see when I use 6s, which is a reference angle of 30 degrees, or pi over 6. I'm going to reverse it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So hold on. 24, I've done 1 revolution, 2 revolutions. 25, 26, 27, 28, 29, 30, 31, 32, 33. So all the way back here, see I landed at the exact same location. Again, it's not actually going to land in a quadrant. It's on that wall, which happens to be the y-axis. Now, whether I convert this one or this one, I'll get the same thing. Either way, I'm multiplying by 180. Let me demonstrate. Taking 22 times 180, in this case I'm dividing by 4, I get negative 990. Make sure to add the degrees and the negative sign. Here, I'm taking 33 times 180 and dividing by 6, and again, I get negative 990. Make sure to add the degrees and the negative sign.